Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.6, day 2, entitled Modeling with Equations. And today we're going to take a look at word problems about mixtures and about time needed to do a job and about distance, rate, and time problems. So we have 3 examples that we need to get through. Now, when we're dealing with problems about mixtures, they have this basic formula that they're following, and it basically says that if you have X amount of a substance and it's dissolved in a certain amount of solution with V volume, then C is going to be your concentration of the substance. And we could modify this equation if we needed to. We could multiply both sides by V so that we had the X, so we had the amount of the substance solved for. Or we could even solve it for V if we wanted to. But this is essentially what we're going to use in our next example. So here we have a manufacturer of soft drinks, and they're advertising that their orange soda is naturally flavored, although it contains only 5% orange juice. A new federal regulation stipulates that to be called natural, a drink must contain at least 10% fruit juice. So how much pure orange juice must this manufacturer add to 900 gallons of orange soda to conform to the new regulation? So you might need to read through this another time or two, kind of talk through it to yourself. But basically we have a company that needs to add 100% orange juice to its naturally flavored 5% juice soft drink so that they end up with a 10% fruit juice concentration in their soft drink. So the next slide has a picture that really helps to visualize what is going on here. So originally we have our 900 gallons of our 5% fruit juice. And we're going to add some amount. We're going to add X gallons of the 100% juice, the actual orange juice. And we want to end up with a 10% concentration. But we're also going to change the volume of our liquid. We're going to have 900 plus X gallons at the end. So basically we're going to take our concentration and we're going to multiply it by our volume. And that will get us the amount of the orange juice. So when we set up our equation then, we'll have 0.05 times 900. That's how much of the 5% juice we had. And we're going to add X gallons of the 100% juice. So that's 1 times X. And we want to end up with a 10% juice. And the volume for that will be 900 plus whatever we add to it, 900 plus X. So now we have our linear equation that we can solve. So 0.05 times 900, that's 45, plus X equals, if we distribute, we're going to get 90 plus 0.1X. Then I have to combine my like terms, get all my variables on one side and all my numbers on the other. I'm going to subtract the 45 over and then subtract the 0.1x over to the other side. That way all my numbers stay positive. So I'll have a 0.9x equals 45, and then I can divide. Remember, when we divide by that decimal, our number is going to get bigger, and I get 50. So 50 gallons, that's the amount that has to be added. So again, you'd want to write your answer as a complete sentence. You would want to say the manufacturers need to add 50 gallons of pure orange juice in order to comply with the new regulations. Now, problems about doing a job. These are actually pretty easy. You just have to think that there is one job that multiple people are doing. So all together, they are doing one job. But individually, they are doing a fraction of that job. So that's the concept that this slide is talking about. So you're basically taking the fraction that one person did, plus the fraction that another person did, plus the fraction that maybe another person did, and all together you have one job that got completed. So we're going to use that concept here in example 7. Because of an anticipated heavy rainstorm, the water level in a reservoir must be lowered by 1 foot. Opening spillway A lowers the level by this amount in 4 hours, whereas opening the smaller spillway B does the job in 6 hours. How long will it take to lower the water level by 1 foot if both of the spillways are opened? So again, you might need to read through this a couple of times, talk through it out loud to make complete understanding of this. But basically we have 2 spillways, spillway A and B, and they're doing one job. So the first spillway does this job in 4 hours. So of that one job, they can do it in 4 hours. So you make it a fraction, 1 out of 4. And together with the other spillway, the spillway B can do one job in 6 hours. So 1 out of 6. And if we add those together, we want to know how long it's going to take them to do the one job together. So they're still doing one job. We just want to know that time that it's going to take them to do it together. So now I have an equation that I can solve. And it's a fractional equation. And we've solved these before earlier in the chapter. Hopefully you're thinking right now, oh, I need to multiply by my common denominator. So we need a number that 4 and 6 go into. That would be 12. And then we also need the x. So really, I'm going to multiply every single term by 12x. And again, you can write it like that, or you can write 12x times 1/4 plus 12x times 1/6 equals 12x times 1/x. So now doing that helps us cancel out our fractions in this equation that we wrote. 4 goes into 12 3 times, so now I have 3x. 6 goes into 12 2 times, so when I multiply across, I get 2x. And then here the x's cancel, so that equals 12. So now I have 5x is equal to 12, and when I divide by 5, I'll get a decimal. That's okay. We're dealing with time here, so we should get about 2.4 hours. Now that should make sense. If one spillway takes 4 hours and the other one takes 6, if you open them both, it should take a lot less time than either of their individual times. Okay, so again, we could convert that decimal into minutes as well. We would have to take 0.4 of 60, and that would be 2 hours and about 24 minutes. So you could write your answer either way. Your book might write it in hours and minutes. If it does, don't think that your answer is wrong. Just convert that decimal of an hour into minutes and check your answer. And again, we'd want to write this as a complete sentence. If this was a quiz or a test and you saw a word problem like this, you would want to say, it will take 2 hours and 24 minutes for both of the spillways to lower the reservoir by 1 foot. That's just an extra slide in case we needed more room to write. Okay, last problem now. This problem is about distance, rate, and time. And these problems are a little anxiety ridden. So, you might be feeling a little overwhelmed by all these word problems. So here's a funny little joke. This is a Far Side cartoon about math, anxiety, and word problems. So you can feel free to read through that on your own. But basically, these problems about distance and rate and time all revolve around this concept that distance equals rate times time. So they might be worded a little bit funky, and we're going to set up a table to help organize that information. But even that table is still going to revolve around distance equals rate times time. So here's our last example, and it's going to take us a little while to organize this and work our way through it. But a jet flew from New York to Los Angeles, a distance of 4,200 kilometers. The speed for the return trip was 100 kilometers per hour faster than the outbound speed. If the total trip, round trip, took 13 hours, what was the jet's speed from New York to Los Angeles? So we're trying to find the original speed that the jet flew in its first part of the trip. So again, you might need to read through this a couple of times. You might need to talk it out to yourself out loud, and that's okay. But the best way to approach these problems is to set up a table. And we've got distance and rate and time. And we have three things basically that we're dealing with here. We've got our first part of our trip and our last part of our trip and then our total. Okay? So we're going to have distance and rate and time across the top. And the first part of the trip was from New York to LA. And the other part of the trip was the reverse from LA to New York. And then down here, this last column, this will always be your total. Or the last row, sorry, that'll always be your total. So the distance of both trips is 4,200. Going there and going back, we're going to assume it was the same amount. Now, we're trying to find the speed that the jet flew from New York to Los Angeles. So our rate is x for that part of our table. Now to find the time, we can find that because we know distance equals rate times time. So if I'm trying to solve for time, I'm going to divide the distance by the rate. 4,200 over x. And we know that on the return trip, the LA to New York trip, the speed was 100 miles per hour faster. So whatever we went on the first part of the trip, we're going to add 100 to it, and that'll get us the rate for our second part of the trip. And again, I can take my distance and divide it by my rate, and that will give me the time for the second part of the trip. Now they also tell us that the total trip took 13 hours. So in my time column, all the way at the bottom, that's where I'm going to put my total. My total was 13 hours. I don't need to really worry about a total distance or a total rate. I don't need to worry about that because for time, I have enough information here. I have this whole column filled up for time. So I'm going to use all of those pieces to make my equation. So my equation, I'm going to write on the next slide actually, because we're going to have to do a little bit of work to work our way through it. But I'm going to take this last column and use it to make my equation, because the time for the first part of the trip plus the time for the second part of the trip will equal my total. So that's why it's nice to make a table like this, because once it's all organized, the equation just kind of is all in order there for you. So here's where we'll do our work. We're going to have the 4,200 over x and the 4,200 over the x plus 100 equals 13. Now again, I have a fractional equation that I have to solve. I'm going to multiply everything by my common denominator. And my common denominator is going to have to be x and the x plus 100. So I'm going to write it this way just to save space on this screen. If you wanted to multiply each individual term by the common denominator, that's fine. But now if I take this first term and multiply it by my common denominator, the x's are going to cancel, but not the 100 plus x. So I'm going to take this 4,200 in my numerator and multiply it by the x plus 100. And in the second term, that x plus 100 will cancel with my common denominator that I'm multiplying by, but not the x. So I have 4,200 times x. And then the 13 doesn't cancel with anything. So all of those are being multiplied together. Now I'm going to have to distribute. So I've got 4,200x, and then I've got 420,000. I still have my 4,200x. Now here I'm going to get 13x squared. Uh-oh. And the 1,300x. Now because I have that x squared, and I have some x's, and I have some constant terms, we're probably going to have to factor or use the quadratic formula. So let's combine our like terms here and get everything set equal to 0. Now the 13x squared is on the right side, so I'm going to move everything over to the right side of the equation. I have 4,200 and 4,200x, so that's really 8,400. So I'm going to subtract that 8,400 over to the other side, and I'm going to subtract the 420,000 over as well. So my new equation then is going to be 0 equals 13x squared minus 7,100x minus the 420,000. Now, I don't know what the factors of 4,200,000 are. I know the factors of 13, but it's going to take a lot of guessing and checking to try and figure out what the proper factors are so that my outers and my inners will add up to the 7,100 or the negative 7,100. So since I have really big, complicated numbers here, the best approach is probably to do the quadratic formula. Okay, so x equals opposite b, so that's going to be 7,100, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so then you need to simplify inside your radical. We're going to leave our 7,100 out front, then I'll have plus or minus. And you're going to take the negative 7,100 squared and then subtract whatever 4 times 3 times 420,000 is. Now that should get you 72,250,000. Luckily for us, that's a perfect square. So that actually comes out to be 8,500 over 26. So now we get our two answers by adding our numerator and then subtracting the terms in our numerator. So if we add, we're going to get 7,100 plus 8,500, and then that'll divide by 26. So we actually end up getting 600. If we do 7,100 minus 8,500 and then divide by 26, we get negative 53.85. And remember, we're trying to find a rate. We have never in our lives gone negative 53.8 kilometers per hour. I don't know how you could go a negative speed. I don't know if that means you're going back in time or what, but that's not physically possible, so that's not going to be our answer. Our answer will be the 600. Okay, and it's actually 600 kilometers per hour. So this problem is not too terrible to set up if you use the table and you organize it. And it is a little time consuming to go through and solve. You have a fractional equation that you end up setting up. And when you multiply by your common denominator, you get a quadratic, and you have to use the quadratic formula. So it's a lot of higher level math skills all put into one problem, but it's not impossible. Every single one of those steps is doable. So make sure you have that example with the chart with you as you're doing your practice problems. And there aren't many of them because some of these problems are time consuming and a little tricky. So if you have questions, come on in and see me before school.